Hello, and welcome to the Critical Power channel for the Data Center Power Design broadcast. I'm Alex Dickens, Content Director at DCD, and it is my pleasure to be introducing this discussion where we'll be unpacking the power priorities of 2025. Now, joining me for this discussion, I'm delighted to be introducing Jeremiah Steichleather, Senior Field Sales Engineer for Global Accounts from Legrand, and Azura Katarina, Head of Customer Strategy for DC Intelligence, who are joining me for this conversation where we'll be looking through the 2025 Survey Mission Critical Mission Critical Power and really unpacking the questions, trends that we saw come up. So delighted to have you both on.
Yeah, thank you for having me.
To kick off the conversation, one of the things we've been hearing about a lot recently is obviously that this trend around density. AI is obviously triggering a lot of change when it comes to kind of physical footprint and our overall infrastructure. But I'm keen to understand, perhaps coming to you first, Jeremiah, how much hype is there around density at the moment? A high density power demand's accurate.
Yeah, a lot of customers are looking at high density power applications, something that, approaches 60 kW, even upwards of 100 kW. But as far as the scale of it, that's questionable because some customers will look at maybe a dozen cabinets at around that density, but then the rest of their data center will be just standard, like 17 kW, 10 kW, or even less. So it really depends on the customer applications and what the customer is doing.
Mm-hmm. And when it comes to the kind of densities we're seeing being deployed, one of the kind of questions right up front from the survey, looked at precisely this. Could you talk us through the findings and anything you found particularly interesting?
Yeah, with these findings from the survey, we found it was around 43% of the customers that had responded said they were doing applications at 60 kW or higher. So, which is really nice, and seeing customers, wanting to push the envelope of what their current designs are set at right now. So what was really fascinating, though, is the fact that some customers are even approaching 100 kW or even higher than that. So lots of cutting edge technologies, cutting edge applications happening out there right now.
Excellent. And Azura, from your perspective, is this broadly aligned with what you're hearing in the market as well?
Very interesting because there is no really a right solution in that respect, or right like KW in terms of rack density. And I think the market is still trying to figure out which is the best available option, I would say. Yeah.
Mm-hmm. And in terms of that kind of red segment on no plans to change, Jeremiah, coming back to you, do you think that that's about right? Obviously, it was highlighted there's a fair amount of demand going on, but almost a quarter of people with no plans to evolve their power density. Does that seem align with what you'd expect?
Yeah, I see a lot of customers that go from smaller applications to larger hyperscale applications. And, AI isn't for everyone, but for the people that are doing it and the people that are looking at it, they're going to have to plan around these high capacities, right? So, where they're getting 100 kW out of an entire pod, now they're doing that in an entire cabinet. So they need to plan accordingly around that, especially when it comes to power as well as space, as well as cooling. So, they have to take it all into consideration there.
Yeah. And, for those operators which are approaching high density deployments, they're going to have to think about it slightly differently depending on the type of project they're tackling. In particular, my mind sort of wanders to kind of retrofits versus new builds. How are, in the field, you approaching these kind of different, data center environments, given, they've got, very unique characteristics?
Yeah, especially for retrofits, we need to look at what's existing and if it's worth the investment for them to literally rip and replace the power that's there. Most of these high density applications revolve around 415 or 400 volt three phase, even some customers going as high as 480. So when it comes to planning around that, your standard customer that's maybe operating at 230 single phase or 208 three phase, they need to really consider what's available for them and what's going to work in their environment. Maybe they have one GPU server per cabinet. The other customer will have 8. It just depends on what's existing, especially for those retrofit applications. Now, if they're greenfield builds where it's brand new, they can actually plan around that, starting from the substation and working all the way down the power chain. So it's a little bit different from customer A to customer B, and if they want to retrofit or not.
Yeah.
Yeah, very, very interesting, Alex. Also, the 23% of no plan to change. I think it's very interesting numbers because not everyone will host high density racks, for instance, or they see any kinds of major changes in their data center.
And I mean, do you see a mismatch the other way sometimes where, a customer may have, quite aspirational kind of rack level design ambitions, but the facility itself, perhaps isn't going to accommodate, densities that high?
Yeah, I see some customers that are like that. And then they have to consider, well, do we build new or do we maybe look at like cloud AI, partners, like, some that are out there that, have 3 letters and provide those cloud-based AI solutions. So more and more customers are going that direction because it's easier and faster to deploy that way with cloud AI providers. But it really depends on, the customer's needs, right?
Yeah, of course. Azura, perhaps you could help provide a little bit more context to the power trends we've been talking about. I couldn't help but jump straight in on the kind of density issue. But in terms of, overall kind of high density readiness and, global power trends, perhaps you could, provide a little bit of insight for us.
Yes, definitely. I mean, the couple of months ago, IEA, which is the International Energy Agency, just published a recent report on data center because it's becoming a very critical industry, specifically for energy, as we know very well. And they give you, and the agency provides a very good understanding of what is the dynamic around the energy and what's the the regional split as well. And something which it didn't surprise me, it was the word let's say CAGR, or the compound annual growth rates from 2023 to 2030. So in these 7 years, they see like a CAGR of 15%, driven mainly from NAM. Obviously, US is one of the key countries of that. And then we see also a slowdown in Europe of 9% CAGR and Asia Pacific with 70% CAGR. If I say region by region, I would say that US is the region that is basically driven this growth. If you think about it, to realize this growth, the hyperscaler need to spend at least an estimated $1.8 trillion US for the capex from 2024 to 2028. And moreover, something interesting from the reports, but also from some consultancy reports like McKinsey, BCG, etc., they mentioned that the average of the US data center will increase from 40 megawatts to 60 megawatts by 2028. And this is mainly driven by AI and, high demand, surge of demand that we are experiencing even today. Saying that, if we look properly at the specific electric market region, something which is not surprise, and Jeremiah can say he might know better, being located in is that the projected construction for data center will be mainly 70% of them located in the PJM area or the Pennsylvania, New Jersey, Maryland area, which also include Virginia and Ohio. Obviously, we're talking also about other regions like the Mid-Continent, Independent System Operator, which includes Illinois and Iowa, and Northwest, including Oregon, and then Southwest, including Georgia. And this is like a trend that we see up to 2028. Definitely, the hyperscaler are driving the growth. if you look at the slides, it's very easy to get to that kinds of understanding that is around 24% CAGR. We see a reduction in enterprise construction, obviously, because it's mainly hyperscaler. And then, yes, as I said, US is one of the key countries worldwide. Europe sees a slowdown for several reasons, including some stringent regulation, land scarcity of land, and constraints with the grids and the electricity at the moment. Yeah. So this is just an overview of yeah.
Thank you. Jeremiah, I'm sure, that wasn't particularly surprising to you, but in terms of, the kind of demands you're hearing as well, particularly from North America, does that kind of match what you're seeing on the ground as well in terms of broad demand?
Yeah, absolutely. I mean, Virginia is constantly a hot spot for growth. It's the center of our data center boom, as well as the Pacific Northwest, like Hillsboro up to Seattle. I mean, we have a lot of areas that we can grow in, and we have a consistent power grid out here, huge customer base. But yeah, that's the direction we're seeing a lot of customers going. So a lot of room for development, a lot of room for growth, especially in certain states that, have tax incentives with our certain customers. So there are certain areas where they like to promote more growth, and, they don't have to pay as much taxes as everybody else. So it just sort of works out that way. So,
yeah. And, when it comes to the demand we're sort of painting a picture of and speaking of, I know during the kind of opening segment, we looked at kind of this issue of high density, but, for the sort of more specific power demands of next gen workloads, as this, graph illustrates, how do you see, audiences being ready in the broader market kind of, being there to, support this build out? Half or almost half said somewhat agree, a good proportion, a third said strongly agree. So the market does seem very in favour of being able to meet that demand.
Yeah, this was an interesting question here, because what we were looking at around 80%, a little over 80%, saying that, most data centers are not prepared for the power demands for next gen workloads. And, that meaning 100 kW plus cabinets. So purpose built data center sites for those AI applications. So as more and more are being built out, they're going towards, 400 volt or 415 volt 3-phase. So that way they're actual, ready for future demands. But, some of those items that are keeping them a little bit, behind the curve right now is the fact that we have very long lead times for building out substations or getting a hand or a hold of, generators and things like that. So we can't just, build them, within the next 6 months. It's a build that happens the next 18 months because huge component lead times are affecting the overall growth of that.
Yeah. Are you finding that the component lead times in the kind of, supply chain itself are causing more challenges, when it comes to building out power than perhaps some of the other challenges around kind of adding more capacity, like, and, sort of power quality, things like that?
Yeah, it's all part of the same. It's all in the same equation, right? So if you can't build out a purpose-built data center for these future demands and you can't get, the equipment, then how you're supposed to install those latest, GB300s in those locations, right? So some accommodations have to be made.
Azura, from your perspective, are we focusing on building out capacity too much and not on other elements around power?
I mean, looking at the charts, I wanted just to add on what Jeremiah was saying, that, yeah, this is plus 82% actually for agree and strongly agree. Data center are not prepared. And I think it's a bit related to the upscaling in some respect. And another way could be also that data center are not they have not upgraded some of the system, for instance, busways or even intelligent PDUs. That could be also something related to that, because it's a huge percentage. So we have to think about all the various options.
Just to kind of mix things up a little bit, we had a question come up during the survey around liquid cooling adoption trends, and I think there's probably quite a lot of alignment as to the importance of liquid cooling within this survey. But are you seeing that market sentiment and general consensus here is reflected in real life deployments of liquid cooling? Jeremiah, I'll turn it to you first.
Yeah, absolutely. Yeah, with high power applications, power translates to heat, and all heat needs to be cooled. So in addition to that, a lot of the new data centers need to be built out where it's really accessible to water and the power is more affordable. So liquid cooling, chip-based cooling applications for a lot of these new customers are going to have to be considered. So because it's outside the realm of standard, air-based cooling systems, crack and craw units. They can't handle anything above 30 kW. At 50, you're talking about rotor heat exchangers, and anything in excess of that, which we're talking about 100 to 200 kW cabinets, need to be, cooled at the chip level.
Mm-hmm. And Azura, please.
Sorry, I'm jumping. Yeah, it's very interesting, liquid cooling, because it's definitely the technology that is the right technology for the right moment. I mean, if you think about not just the rack density, but the cost efficiency that we can reach with the liquid cooling, but also the sustainability, which at the moment is also is one of drivers for also the constraints of the data center market. And definitely is becoming more and more critical. And this chart, this graph, just pivot that. I would say the liquid cooling, and when we talk about liquid cooling, is direct to chip and immersion liquid cooling. We see more adoption, let's say, in direct to chip cooling. But it's also interesting to see which one in the future might drive more and the growth. I mean, the growth is huge. There are several, I would say, speculation around the liquid cooling because it's just started, I would say. So some figures talk about around 25 CAGR for the next 5 to 6 years for US specifically, because we see the implementation of liquid cooling more in US and also in Asia, China specifically. But yeah, US is the country for many liquid cooling companies as well.
Mm-hmm. Fantastic. Well, appreciate you sort of taking a bit of time to segue into the cooling side of things. But to bring it back to kind of the pure power side of things, I'm interested to dig a little bit deeper into a couple of the points which came up during the survey, particularly related to power management technologies. Now, I mentioned earlier, how good are we at kind of monitoring power quality? Are we putting enough emphasis on this? And actually, that kind of leads me to this question, which was during the report, which looks at what are the trends we're seeing when it comes to, power monitoring quality. I guess looking at this, Jeremiah, is this kind of broadly in line with what you would expect, or were there any surprises here?
Yeah, it's in line with your customer expectations. Everybody has to have some level of monitoring from either the individual outlet level or getting down to the rack PDU or even at the RPP. But as we're approaching, these new AI applications, we need to monitor everywhere across the board to make sure that, we're not drawing too much power in certain respects, in certain locations, as well as the power quality. You want to monitor for total harmonic distortion, things like that. So that way you're not having any other, power quality issues with your power supplies at your servers. So, you want to have some means of measuring and monitoring all this data, at almost every single point in the power chain. Because if there's a failure, you want to get a notification about it because it'll minimize your downtime as long as you are getting those notifications.
Yeah. How do you avoid kind of provisioning for this without overkill? All of the above. I suppose that's to kind of make sure that you've got a certain level of reliability in your data center. But do you think we'll see more and more of these kind of all of the above answers as we see higher density workloads and potentially kind of more critical workloads permeate?
I think so. I mean, AI will eventually be reporting on themselves saying, hey, this is how much data I'm actually reporting, but it needs to have their checks and balances. So you need to have another means of, measuring and monitoring those data points and not just relying on just one individual, source. So we're going to, I think, continue to see it, all of the above when it comes to, questions like this, where do you monitor, your power quality at?
Mm-hmm. And similarly, Azura, from your conversations from kind of your old role at Schneider, how have you kind of seen trends when it comes to monitoring power quality evolve, and how have those kind of changed in recent years, particularly in light of demand for higher density and for more power overall?
I mean, definitely, I agree with all of the above, because you need to track it, to monitor the power quality everywhere in a data center. Definitely, I think with the adoption of AI will be also the adoption of AI in the AI data center. So there will be like a major tracking with the AI system, with the data center, with the advanced energy management system, which is like the advance of DCIM, data center management software, basically, that can track and monitor the power and the everywhere in the data center, basically. Mm-hmm. So yeah, I think with like Jeremiah, we'll see this all of the above increasing maybe in the next years.
Mm-hmm. I also like to jump on one of the things that Jeremiah mentioned about kind of monitoring faults, at the outlet and device level. What are the trends you're seeing when it comes to this? And as we've got quite nicely outlined in this chart, we've got a bit of a sense on how well tools have helped people with their kind of current monitoring. Does this surprise you?
What surprised me was the 35% of people looking for options. So we had 13% saying, they don't have, outlet level or device level monitoring, and 22% says, they're looking into options. But I would say out of the 35% that's reporting there, they probably didn't realize that was an option for them. And now they would have to essentially rip and replace products in order to get that, device level monitoring, because they didn't know it existed in the first place. So that part was a little surprising to me. But the trend, I think, is going to push more towards where that 40% is, where they're, they actually have it and they're looking to upgrade, right? So that piece of the chart's going to grow.
Yeah. How can we kind of make sure we're doing that and kind of scaling our tools, improving our tools in a way which is, kind of as cost effective and as sustainable as possible, particularly as we're kind of pathfinding our way to higher densities?
It's just a matter of having the conversation, with the customers, making sure they're aware of, what data points they want to monitor, and making sure, they can, understand what's available to them.
Mm-hmm. And I guess, question to yourself, Jeremiah, or Azura, if you'd like to jump in as well. I know we've spoken a fair bit about, AI automation when it comes to power management technologies, but do you see these, taking a far greater role, in the not too future in terms of managing not only kind of power, but, all systems within the data center?
Yeah, I see that happening eventually. I mean, there are currently systems that actually do that, or they actually will move their AI workloads from one section of the data center to another, because they are monitoring data points for temperature, right, and humidity and whatnot. So they want to move it from, an area of the data center that's hot to another area of the data center that's cool. So yeah, AI tools will further enhance what they're doing inside the data center space.
Yeah, I completely agree. And I was quite surprised about, as Jeremiah said, about this 35% of customers that they're still figuring out how, to identify, remediate faults. Most likely might be like a skill upskill in a data center facility. But yeah, I doubt that this will be happening in the next couple of years, because the software will be more and more implemented, especially in the new greenfield facilities. And obviously brownfield as well. I mean, this is like a basic requirement, I would say. If Jeremiah, if you can say more, because you are more close to the customer. But yeah.
Yeah, absolutely. In those greenfield builds, they will be utilizing those new AI tools to help manage their sites. So it'll be AI helping build AI.
Yeah,
Right.
It'll be interesting to see how those pie charts shift, in particular over the next couple of years. As we see automation become more mainstream. In terms of that kind of more mainstreaminess as well, I'm always keen to understand, what's happening when it comes to adoption trends, and where, we're talking about these kind of adoption curves and who's implementing these kind of next gen systems. But what is the kind of reality of, who can actually afford kind of advanced power management tools? For the audience, I know this writing might be a little bit small, but it asks, how much do you agree or disagree that only hyperscalers have the resources to invest in advanced power systems / the latest infrastructure upgrades? I guess, the question to you, Jeremiah and Azura, is whether, from this question, can we infer that perhaps people are looking at advanced power management systems being, a little bit too mature and only available to organizations like hyperscalers? Or is there kind of broader market adoption when it comes to this next generation of technologies?
Yeah, it's sort of perceived amongst a lot of customers that only the big hyperscalers can actually do this, but there are more and more tools available for the mid-market customers, like cloud AI systems, where they can actually pay per cycle if they wanted to, and those will become more readily available and more affordable to those mid-market customers. But it was interesting to see from this response where we had essentially around 31%, saying they somewhat disagree or strongly disagree that only the hyperscalers have the resources. So there's some people are realizing that those options are out there for them.
Mm-hmm. And
yes, definitely. Yeah, the options are there. And I think it's just not the hyperscaler, but also the top collocators, the medium collocators that will invest heavily. I mean, obviously the question is a little bit tricky, because if you look at the latest release from internet giants, for instance, how much they are investing in artificial intelligence and CapEx, and how much they're committing. And I just give you some example from the newsletter. Like Microsoft is committed to 80 billion for the next years, and then Google, Amazon, the same amount, between 50 and 75 million. AWS again is investing 100 billion in hyperscaler data center for AI particularly. So I really think that when you see these kinds of news, you are tend to believe or think that just the hyperscaler have that kinds of amount of investment for higher advanced AI data center. But I mean, we know in reality it's not just them, but the top colos and the top customers, I would say.
Mm-hmm.
Yeah. And that you'll see from this chart, 30% are not really sure. That's going to shrink because they'll discover that, there are more tools that are out there like AWS, Google, Oracle, CoreWeave. A lot of these people are out there, able to provide solutions for those customers that are looking for it and able to, turn it up within a day. instead of having to wait 18 months to build out their own site, right?
I do appreciate that this was a bit of a whistle-stop tour conversation. We kind of looked at the lay of the land when it comes to power in quite a lot of depth and quite broadly. But, what I'm keen to understand is how power is likely to shape up in the coming months, in the coming years, and likely what next year's edition of the survey might say. I guess to kick us off, obviously, we're seeing huge amounts of investment into power, which is showing no slight signs of slowing down. But as the AI hype curve kind of, it might go up, it might plateau a little bit. But what impact might that have on, how we're thinking about, next gen power solutions in other ways, which perhaps this report didn't address in so much depth? What I'm thinking is stuff like long duration storage and innovative technologies like SMRs. Do you think they'll become a bigger part of the conversation in years to come?
Yeah, absolutely. Especially with future built, even like in today's data centers being built out now, the utility companies are sort of the gatekeepers to whether a data center can be built or not. Like in the Virginia market, they're sort of running out of power, so they're going to have to sort of check data centers as they're being proposed and planned. That's why Ohio is seeing so much more growth for the data center market, as well as the Dakotas. But utility companies are going to reach partnerships with a lot of these, data center companies. They're going to come into an agreement for like a fixed rate for their energy usage, or they're going to build out at sites that can provide, easy access to solar or water, any sort of renewable energy sources. That's really going to be the direction for where the growth is going to have to occur. When it comes to maybe long duration storage shifts, you can't really operate a lot of these AI applications off of lithium ion batteries because they're going to consume so much power, more power than those lithium ion batteries can, charge back up into. So they're going to have to look at those alternative solutions, which are sort of on the sidelines now, but they're all going to come right into focus for those future deployments.
Brilliant. Zura, what's your perspective?
Yes, just adding up on what Jeremiah was saying, I think that the power constraints in terms of availability would be the first, in a way, opportunity to create something different like microgrids, for instance, and increase the use of renewables. Because, the grid can hold until certain extent the growth of the data center. If we think about that, for now, in the next years, it will be around 180 gigawatts. Then energy needs to come from something else. So microgrids could be a solution. And obviously, the implementation of microgrids can come along in parallel with the increase of renewables for data center. I also think the AI automation technology will play a fundamental role in the future of power. We see just in other energy sectors, like, for instance, Nokia developed some energy consumption software for their telcos and to support in case of, the real demand of the energy. And we see also that implemented in Tata Power in Asia. So I really think this will be the future in respect to data center, AI automation, and new source for power.
Yeah, microgrids would be huge, especially when it comes to the SMRs, the small modular reactors.
Also small. I wanted to say also small modular reactors, but small modular reactors, which could be sometimes, I think, the solution. The main constraint is the regulation and the regulatory environments, which in some region, Europe, not just Europe, also US, some states, is quite stringent in terms of nuclear. So microgrids, I think it would be the short term in the next 5-year solution. Even though the growth, if you think about it, from the latest, for instance, Statista, is 15% CAGR in US, but we're talking about small numbers. So it's still a huge growth. It's double digit to support the center facilities.
Nice. I guess Jeremiah, Legrand brought us here today to have this conversation, so you get the final word. I guess in terms of, say 12 months' time, we're putting together another survey. What do you think the kind of key question will be when it comes to kind of data center power evolution in the 2026 edition of the survey?
I think that in the next survey, the key question would be: are you looking at power capacity plans for the future, and what direction are those headed in? Because everyone's going to be looking at this. It's not just hype; it's reality, and they need to look at what they can do and what other options are out there if they can't deploy something sooner than later. Because nobody wants to be left behind, especially when it comes to mission critical applications. For Legrand, we're here to help all of our customers build out their infrastructure. So as they're looking forward towards future growth, they're going to have to make sure they plan accordingly. So.
Excellent. Well, early planning and thinking about it now is by no means no bad thing. Guys, I really appreciate you jumping on the call for this conversation and to talk about the survey in more detail. It's been a great conversation. Appreciate it.
Yeah, thanks for having me. I really appreciate the time. And it was very nice meeting you all virtually.
Nice meeting you. Thank you, Alex.
To our audience, thank you very much for tuning in. If you did miss anything, this episode will be available on demand shortly. You can also download the survey from the resources section on the bottom right-hand side of your screen. If you do have any questions, please do reach out to Jeremiah, Azura, and the Legrand team. They'd love to hear from you. Otherwise, we've got another episode next, so stay tuned.